Hello, SSEF judges. We are pleased that you have taken the time to judge our project. Our project
Title is Effects of Sugar on Lumbricus terrestris, in which we sought to see if sugar level had an effect on red wigglers or Lumbricus terrestris, a common type of earthworm. In more recent years, people have begun to move to more organic lifestyles, buying locally or home-growing produce. In fact, more than 49% of Americans had tried to grow plants at home, according to a study in 2018. Worm casts are the worm's fecal matter, the very thing that makes them so good at helping plants grow. The NPK scale is a scale that measures the levels of nitrogen, phosphorus, and potassium. Worm casts on the NPK scale rank very low at a 1, 2, 0 rating. While synthetic fertilizers rank very high on the NPK scale, the effect is greatly exaggerated. Plants do not receive all of the soil's minerals and thus cannot digest all of it. Worm casts, however, do not depend on the NPK scale, but rather the microbes produced after digesting organic material. Further, factory-made fertilizers can be harmful for the environment by mixing several nitrates and minerals into local lakes and rivers, causing poor living conditions for aquatic life. The farming of worm compost, known as vermicompsting, is a growing community that promotes recycling old food and table scraps to the worms to produce eco-friendly fertilizer. As of now, however, there has not been a set food type in which to feed the worms for maximum result in the worm casts produced. This study sought to find if different sugar levels when fed to the worms had any effect on the efficiency of the casts produced.
To conduct this experiment, sugar levels had to be chosen. This was done by selecting fruits that had varying levels of sugar. The three that were chosen were mango, watermelon, and tomato. Mango having the highest relative sugar concentration, watermelon at a medium, and tomato at a relative low. Each fruit became a group, with 5 pots per group. A fourth group was added, this being the control group, to which the other groups would be compared to find a statistical difference.
Our null hypothesis for the experiment is the sugar fed to the worms will make no statistical difference on the efficiency of the casts produced by the worms. To refute or accept this, the data was collected for the fruit groups were compared to the control group to see if a statistical difference was present. Our alternative hypothesis being different levels of sugar will show a statistical difference in the efficiency of the casts produced.
In the researcher's procedure, one worm was placed inside each of the pots excluding the control group. Each pot was designated with a fruit and was fed a blended form of the fruit to allow it to seep into the soil. The worms were fed every 2 days. Poppies were planted to grow in each pot, and the plants were watered on the same day the worms were fed. The growth of the plants was measured every 2 days and recorded. This would allow for a comparison to show a statistical difference in the efficiency of the worm casts.
During the experiment, the worms did very well and were all placed into the ground after the experiment. The tomato group by far did the best and was the first group to germinate. 2 days after the first germination, however, the entirety of all the plants had at least germinated. Tomato at the beginning grew very rapidly and developed thick purple stems. The control group, while nowhere close to the tomatoes, did fairly well and developed small purple hues to the stems. Mango and watermelon did very poorly. The average growth rate for both was around 0.1 centimeters. The stems seemed very weak and the plants did not develop any purple hue at all.
The data collected in the study shows that we can successfully refute the null hypothesis by comparing the control group to each of the fruit groups using a t-test. The only group to show a significant statistical difference was the tomato group. This shows that the lower levels of sugar when fed to the worms will improve the effect of the worm casts produced. A step further would be to say that the higher levels of sugar actually harm the efficiency of the casts. The constant high level of sugar diet for the worms may have had a negative side effect on the digestive rate of the worms and may have had a negative impact on their health.
Some problems the researchers encountered while working on the experiment was a lack of protective tarp over top of the worms and the pots. The screen used to line the bottom of the pots was used to cover the top. This ensured both the protection of the worms from predators and from the worms escaping from the top. Secondly, food delivery became an issue. The pulpy fruits would not easily go into the soil, and instead sat at the surface. This was quickly realized, however, and to rectify this, 500 milliliters of water were added to each ration to dilute the food. This allowed for the food to seep deeper into the soil where the worms potentially be. Lastly, a possible negative factor may have been the colder weather during the latter days of December, as the worms may have been less active in the cold.
The information found in this study has multiple real-world effects. The research has formed the basis for what to feed worms in order to produce the maximum product. Local levels of farming can benefit in worm casts as they provide greatly effective fertilizers that are cheaper than store-bought alternatives. To progress the research of worm composting, several other tests could be conducted, including testing to see if worm cast efficiency is dependent on temperature, as the cold weather may have impacted the experiment, or if movement area affects the efficiency of the cast made.
This concludes our presentation. We are again glad that you have taken the time to judge our project, and we hope that we are a strong consideration when you make your decision.